You remember in the last video, the crane was about to tip over if the boom was less than 70 degrees. So I want to get the boom down to 45 degrees, and it's going to tip unless we got a counterweight. 4.7 pound brick. Now we can go down to, well, let's see, to 45 degrees. I've got a protractor in the back that you can't see that tells me the degree readings. There we go, 45 degrees. It's not going to tip over. So we have to run the numbers again. So on one side we have the crane body, which was the 84 inch-pounds. Remember that? Now we have to add the counterweight, 4.7 pounds. And we get 150 inch-pounds. How do we get that? Weight times distance, remember? The weight is 4.7 pounds, and the distance we measure from the, hold on. That's why it's good to have somebody else help you with this. So, 4.7 pounds, the center of gravity of the brick, the distance from the center of gravity, which is the same as the line of force, from there to the pivot point, there's the pivot point, so from here to here is 32 inches. So weight times distance, 32 times 4.7 gives you 150 inch-pounds. Combine them, we get 234.4 inch-pounds. So we combine the torque of the counterweight and the crane body. Did I tell you what torque is? Probably not. When you have a force that causes rotation, that's called torque. The weight on the two arms causes the whole thing to rotate around the pivot point or a fulcrum. Same thing when you open a door. The door will pivot around the center point, which is the hinge. Same thing with the crane. It pivots around the fulcrum. Okay, so we've got 200 and some odd. So we've got the torque of the crane body and the counterweight. Now we have to, on the other side of the equation, is the load and the boom. So the load is that same 4.7 pounds. And the distance is from the line of force, which runs through the center of gravity of the load, to the pivot point. Now remember I said most of these measurements are pretty crude, so we're going to go with the idealized measurements that we get with trig. Where's my next poster? There we go. Okay. So now we got 45 degrees for the boom. We want to find the distance from the pivot point to the line of force, which is way over there. So cosine of 45 is 0.707. Where's my helper? Can you see that? Cosine is adjacent over hypotenuse. I hope you remember that. The cosine of 45 is 0.707. The hypotenuse, which is the boom, is 45 degrees, 45 inches, and the adjacent side is the distance. That's what we're trying to find. So we substitute the numbers, and we get a distance of 32 inches, which is actually the same distance we had on the other side. Remember we added, for the counterweight, we added 4.7 pounds times 32 inches, and we got 150. So we got the same thing over here. We got the 150 added inch-pounds. What about the boom, you say? The boom weighs 2.2 pounds. See, I got a better picture here. Yeah, okay, here we go. So we need the center of gravity of the boom. which is 22 inches from the pivot point, from my poster of yesterday, which I don't have now. So the whole boom is 45, the CG of the boom is 22 inches from the pivot point. So in our calculations, the hypotenuse instead of 45 is 22. And we use the same 45 degrees cosine. Now you're going to have to do some work now. All this is the same, except instead of 45, it's going to be 22 inches. And the answer you're going to get, well, you check, see if I got the right answer. Weight times distance. The weight is 2.2 pounds. The distance is 15 point something, I forgot. You figure it out and see if you get the same answer that I do. I got 34.1 inch-pounds. Combine the two, you got 184 inch-pounds, which is much less than the 234. So it didn't tip over. Remember, all these numbers are very crude because the measurements are not very exact. Have you heard of safety factor? Remember when we had the boom at 70 degrees, and if we moved it to 65 degrees, the whole thing would tip over? Well, cranes do tip over, but there's one thing called the safety factor, which hopefully we're going to use too. If you've got a crane, let's say the crane weighs, let's say the load weighs 100 pounds. To be safe, if the load and the boom weighs, let's say 100 pounds, the other side of the equation, the crane body, should weigh 150 pounds. That's a factor of 1.5. So, if we've got a load and a boom that weighs 184, to be safe, we multiply 184 times 1.5, and that should be the total torque of the crane body. I don't have my calculator here, so you'll have to do it yourself. But it's going to be more than 234. But still, 234 is, maybe it's not 1.5 greater than 184, but it's a good deal greater, which is why we're pretty safe with the crane at 45 degrees with one counterweight. Let's see. Now, is raising or lowering the load going to have any bearing on whether the crane wants to tip over? No. The only difference is the angle of the boom. Well, let's see. Instead of running the numbers, let's just see how far down I can go. So we've got about 30 degrees now. It's about to tip over. So if the boom is at 30 degrees, you run the numbers, see what you get. The boom is at 30 degrees. Everything on this side of the equation stays the same. The torque of the crane and the counterweight stays what it was before, which is 234, I think. The weight of the load is the same, but this distance is much greater. Same thing, the distance from the CG of the boom is greater than it was before. So these numbers are going to be pretty, we don't have a safety factor here, so this is not good. Because let's say it's a windy day and the load starts to move, that could tip the whole crane over. Okay, that's enough for this video.